Hi everyone, and welcome to this Ferncast webinar exploring the technology of modern radio streaming. I'm Virginie from Ferncast Marketing, and I'm delighted to have you with us today. Over the next 45 minutes, Ferncast experts will dive into cutting-edge streaming formats, essential protocols, high-quality encoding, and customers' use cases for major broadcasters. You will discover how Xstream software can streamline your audio workflows and boost your reach across Icecast, HLS, Dash, and RTMP. We will also have a Q&A live session at the end of the webinar, but feel free to drop your question in the chat during the presentation. And yes, as always, you will have the chance to win a Ferncast t-shirt by participating to our traditional quiz, so stay tuned. And one last note before we begin, the recording of this webinar will be sent to you by the end of the week. Let me introduce now the speakers of the day. Bernd Geiser, Senior Audio Engineer at Ferncast, Thomas Schlien, Senior Software Engineer at Ferncast, and Tobias Dornbusch, our product expert. Let's now have a look at today's agenda. After a short introduction to Ferncast and the Xstream platform, Tobias will dive into streaming protocols and formats. Then Bernd Geiser will share information about encoding with HEAC and Dolby Atmos, and also will explore metadata insertion. Then Thomas Schlien will showcase technologies for workflow optimization, audio processing, and loudness control. And finally, at the end, Tobias Dornbusch will share use cases from WDR, RNE, and Klassik Radio. I'm going now to hand over to Tobias Dornbusch, who is going to give you a short introduction to Ferncast and Xstream platform. Tobias, the floor is yours.
Okay. Yes. Thank you, Virginie, for the handoff and the opportunity. Yes. As you are hopefully aware, we are a Ferncast. We are an audio logistics company, as we like to define ourselves as. And this means, of course, that we offer solutions and services for just about any kind of audio encoding and transport and the like, which is, of course, also part of the expertise that we are displaying today in regards to radio streaming specifically. And the core solution that we offer is so-called Xstream, as you can see here on the screen, which is a software solution based on is a Linux operating system that you can install on just about any kind of hardware, conventional servers, mini PCs. You can also install it virtualized or in a Docker container. And this, of course, also means that you can run it in the cloud, which we also offer as a service for you. And of course, this has quite a few different advantages for you as the user and by extension also your listeners. So since it's a software solution and with the way it is designed, it is highly flexible. So we pride ourselves on supporting almost any kind of input and output as far as audio transport is concerned. As a software solution, it's also infinitely scalable. So compared to conventional hardware encoders, which has, of course, which have hardware limits to the number of encodings that they can use or how many inputs and outputs they can support, a software solution, of course, based on the hardware, can be scaled to whatever size you need. We will actually see some examples of how far you can go there later towards the end of this webinar. You can also combine multiple applications on the same system. What those applications are, we see in a moment. All of this, the scalability and flexibility, of course, makes it also a very cost-efficient solution, especially if you take full advantage of the scalability and the flexibility. And as I mentioned, since we also offer this as a software as a service subscription model, this also means that it is possible to start with a very low cost entry. Yeah. Talking a little bit about the applications. So to give you a bit of context, what this actually means when we say we support all this variety of inputs and outputs and so on. We have a list here of both different kinds of applications that we support. It's not fully comprehensive, but it gives you a very good idea, I think, as well as some of the specific platforms that we offer. So one of our core expertises, I would say, is in fact the streaming that you can see on in the left column there, in fact, with which we mean online radio streaming. This is how we started. This is where we have put in the most development, as you will also see here today. But from there, we spun off to different use cases, from audio over IP communication, like SIP, WebRTC, that sort of thing. Contribution, of course, very similar in that regard. Muxing, DVB compliant, MPEG-TS, various kinds of transcoding, and studio transmitter use cases, so any sort of audio transport in high security and high reliability, but also demuxing existing ensembles, muxes, and so on, and then format converting that or using it for monitoring use cases. So we have, for example, a use case where a customer receives an existing DAB ensemble from the air and a format converts that into their radio streams, actually. So reusing the same signal there. And last but not least, we also support non-live use cases with podcasting. And because of that, we have a great variety of, we like to think, very happy customers in different areas. Of course, as you can see here, mostly broadcasters, mostly public broadcasters, but also some private broadcasters, and actually the police, because we're also active in security relevant audio transmission and recording logging in general. And one way how we actually achieve this technological expertise, besides what we of course ourselves bring in, despite being a fairly young company, we are very proactive in working with different partners. And here you can see a selection. Some of these will, of course, also become relevant today, looking specifically to Timeo Audio Technologies and Fraunhofer, and, of course, Dolby Atmos, as you will see later. Okay, that's enough for a quick introduction to the company. Now I would like to move on to the first proper part of the webinar, which is a quick introduction to the conventional or currently used streaming protocols and formats. So, broadly speaking, you can actually separate the streaming formats into two kinds. One I've dubbed here just conventional. There's really not a particular name for this, but it serves to differentiate it from segmented formats that we will get to later. These quote-unquote conventional formats are very much how you would imagine a web stream to look like. So you have a continuous stream that is pushed onto the net, and from there, from like a CDN, you receive those streams, those duplicates of streams as clients. It's fairly straightforward. However, with this very straightforward approach, there's also some downsides or issues that segmented formats have solved. For example, if you have variants of a specific stream, that is to say, different bit rates, different languages, maybe even other special technologies in use, then those are in fact different streams that the user, the client, has to intentionally choose. The upside of this is, of course, that at least, especially nowadays, almost any kind of end device will support those kinds of streaming formats because, again, they're very straightforward. And talking specifically about the high compatibility here, we, of course, first come to Icecast, also Shoutcast, though this is now a less popular variant, which is also an HTTP-based stream. So in that sense, a modern technology is actually open source, although there's a foundation that is specifically working on it with actually also a company that we are, or an organization that we are in close contact with, via a library called libshout that is doing the processing for the Icecast. That's pushed or distributed to the CDN, and from there, of course, made available to the listeners. Relatively high delay, of course, that's not a major concern usually in web streaming, though it can be because Icecast is also quite often used as a monitoring source. Then we also have RTMP, though this one is, especially nowadays, hardly used in audio-only streaming. There's still it still finds a decent bit of use in video, especially, which makes sense because it came originally from Adobe for Flash Player specifically. But even in those cases, it's more often the case that, and as you can see with the diagram on the right, an encoder is sending an RTMP stream to a media server or a CDN, but then this server is actually then repackaging it as, for example, HLS, and that's how it is pushed to or brought to the clients, to the listeners. What HLS is, if you're not aware, we're of course going to talk about that in a moment. Nonetheless, development on RTMP continues. Fairly recently, actually, enhanced RTMP was specified, and that is in fact the RTMP variant for more modern codecs, especially as far as things like multi-channel encoding, immersive encoding, and so on is concerned. So it is definitely still used, but very much not so much in audio, in radio specifically. But talking about formats that are suitable for delivering to the CDN, who then repackages it in a different way, we should definitely talk about SRT. SRT is not streaming format in that sense, in the same sense that Icecast and RTMP are. It is more a conventional transport stream for media, transport format for media, in the sense like RTP might be, for example. However, it has a lot of features, a lot of mechanisms that makes it very reliable, very secure, as is in fact the name of the standard. So including an end-to-end encryption that is built in, repeating and forward error correction mechanisms to reduce packet loss and keep the audio quality, the media quality high, the ability to package other kinds of formats into it, like having an MPEG-TS that you transport via SRT, or even an EDI, if you're familiar with that is. That is, of course, the DAB over IP format. And yes, getting back to the initial point, if you have an encoder that doesn't actually support native HLS etc. packaging, then SRT might actually be a good way to deliver your media to the CDN from where it is then packaged in the required formats, because it's just so secure and reliable. Which brings us then to what we already talked a little bit about, segmented formats, specifically HLS and dash, as we will see in a moment here. So what happens in a segmented stream is, as the name implies, the media that you're sending isn't actually this continuous stream in a sense, but more like it is, well, segmented into small parts, which are then downloaded one after another on the client side. Of course, as far as the client experience is concerned, it is a continuous stream because, of course, this happens at high speeds, but on the technical layer, it's not quite that. Manifests are used to order these segments, sometimes also referred to as playlists, so that the client knows, and also the CDN and so on, how the segments are ordered in case they don't arrive quite in the intended sequence initially. This segmentation does have one very, very important advantage, and that is that since they're actually just tiny files that are downloaded one after another, it means that those files need to actually be available for some time. Now, of course, this means that there have to be at least a few seconds of different segments, but in a lot of cases, you can actually, or the CDN can keep minutes or even hours worth of content, you know, before discarding them, and that is how you get time shifting. That is to say, the option that a client can actually jump back in the stream and listen to, for example, what was talked about or the music that played an hour ago. And this also means that you can actually have multiple versions of a segment ready, which is then useful for things like multiple language support and so on. And yeah, as I mentioned, there's mainly two types of segmented formats: HLS, which is HTTP live streaming, and MPEG Dash, or simply Dash, which is dynamic adaptive streaming over HTTP. As you can see on the left, HLS was first specified by Apple and is in fact still their household streaming format. As designed, is also suitable for both live streaming and on demand. It really doesn't matter much with segmented formats. If you see it in the wild, you can identify this with the M3U8 files being the manifests to start the stream. The Dash, meanwhile, was specified by MPEG and is in fact similar to HLS in a lot of ways. However, specifically from Apple, the support isn't that great. Of course, by this point in time, most end devices or players anyway would support both, but you still have to sometimes be careful. And yes, as I mentioned, the manifest here are MPD files. This will be referenced in a moment again for a lot of the advantages of segmented formats I already talked about. The time shifting, of course, we talked about. Another element is adaptive bit rates, which is the functionality that when your player recognizes that, for example, the bandwidth isn't sufficient to keep up the current bitrate quality that you're receiving. You know, there might be dropouts and so on because the bandwidth is too low and so on. The player can actually switch to a lower quality stream because, of course, the segments are differently encoded segments are available, and you simply need to switch which segments you would be receiving. But there is not a significantly noticeable stop in the transmission in that case, or not necessarily anyway. The segmentation is also very advantageous for integration with other technologies. We're talking specifically about things like live transcription and subtitling, which oftentimes, especially now, also use these segmented formats to do things like the timing and so on. And sort of connected to this, both HLS and Dash have ways to handle different variants of a stream. HLS is arguably a bit superior in this regard in that their the renditions can be announced specifically and more dynamically switched, while in Dash, the track, as it's called, often or has to actually include all the information in the same stream, which is of course not as nice for bandwidth. then talking about the versus, kind of started with this already. Actually, for radio broadcasting, the differences are minimal. In our experience, HLS is certainly more common in radio, simply because with the rendition groups and so on, it is just a bit more advantageous. And although the encoder support for HLS is a little smaller than for Dash, this isn't usually an issue in radio, where in most cases there's only a limited selection of audio codecs that are really used in common use anyway. Which, of course, for HLS is usually AAC. Specifically in our solution aixtream that we talked about earlier, it's also nice because we can actually do the entire segmentation and including having different variants with different playlists in the encoder itself, which is sometimes, which is often otherwise something you have to rely on the CDN doing. Just a quick diagram of how you could imagine a backup scenario looking like with a segmentation. So you see, of course, the same segments are being produced by the primary and the backup encoder, but and of course synchronized as well. So simply picking up on the segment following the one where you lost connection is very simple. And as we mentioned, with like the time shifting and so on already being supported, there wouldn't even necessarily be a gap in your streaming experience, because even if there's a connection loss, you can still pick up, with the segment that was following the one where you lost connection. Last but not least, I would quickly like to talk about CMAF, which is the Common Media File Format. So as is so often the case with standardization, obviously, you don't actually end up with one standard that everyone uses. That is, of course, why we have HLS and Dash. Nonetheless, the requirements of the media industry and so on mean that people do want standardization, and that's why we got CMAF, which is effectively a way to package HLS and Dash in one format, which, of course, then achieves maximal compatibility with the end devices. So it uses a standardized container format, which is the fragmented MPF, FMMPF, MP4, sorry, and standardize the length of segments and so on. Nonetheless, you have to still watch out for things like when you're using additional technologies with the compatibility. For example, if we're talking like about the encoding here, simply because you're using CMAF, that doesn't necessarily mean that your HLS streams will then encode in a wider variety of ways and so on. And with this section is done, and I would quickly like to start our question for today. And that is also, of course, related to radio streaming. When was the first continuous live online radio program launched? With continuous here, we mean, of course, not just a single show or program, but a long-running program. And with that, I would like to hand off to Bernd.
Yes. Hello. So yeah, please post your answers to the quiz question in the chat. So, and the first one will win, obviously, as always. Maybe you know it. Okay. I will quickly share my screen. Okay. Yeah, Tobias has talked a lot about streaming formats and also mentioned the codecs, and often the ones he mentioned are also the let's say bread and butter codecs, AIC, mostly in modern technologies, but MP3 is still alive and well and often used for compatibility mostly. I will shed a light a little bit on newer technologies in that regard, which is the XHE AIC and the Dolby Atmos format for spatial audio and immersive streaming, which can also be a use case for radio stations, as you would see. Okay. The XHE AAC is devised by Fraunhofer as the original AAC as well. It is also standardized under MPEG, and that stands for Extended High Efficiency AAC Profile. In MPEG, it is called USEC, which stands for Unified Speech and Audio Coding. Every MPEG audio codec has this audio object type. It is 42, if you encounter that, which is for XHE. XHE is not a codec. It also includes methods to deliver consistent volume and loudness to the listener. So it incorporates dynamic range control and loudness control components standardized in MPEG-D. The operating range is remarkable. Even in stereo, it's from very low 12 kilobit up to 320 kilobits, which is quite wide. And later I will give you a brief example on how that codec sounds at the very low end, because that's all you can judge over that Zoom connection, which is re-encoded again, I guess. Okay. One thing which is very interesting is the bitrate switching, which Tobias already mentioned can be done with HLS or Dash. And with XHE, it is taken care of that switching can be seamless. So if the network conditions change, the bandwidth allocation has changed, then the audio can be seamlessly adapted to another bitrate. And that can be even very low. The decoder has integrated loudness control, so you can have a consistent volume, and you do not have to take care actually anywhere else in your chain, because the codec takes care of that very well. There's also dynamic range control with profiles that can be selected, and one example which is very interesting, is a profile for listening in noisy environments. That's also included in the codec. Yeah. Our product, the Xtreme, can package XHE AAC in HLS, and here's an example manifest of how that might look like. You recognize that in that codec signature here, which is here you see the 42 again, yeah? And we have a 3 bitrate playlist here with 24 kilobits, 48 and 64. And there's some overhead, and that's how you come up with the slightly higher numbers here, because there is a container format. Yeah, the segments are fragmented in MP4, this fragmented MP4 that already Tobias mentioned. Take care, XHE AAC is limited to MP4. You cannot really, let's say that the support for XHE in MPEG-TS is not very good, or it's so most players won't just play it. So the standard way to deliver that is MP4, the easy file format. Okay, I'll go back. Now I have 2 examples. That's a music piece encoded in stereo, which you can just listen to and start with 24 kilobits per second and then go down to 12. Clear, you will notify artifacts. It's, of course, a low bitrate, but as I think, it's still usable for very narrow connections. And then just imagine hearing that on smartphone speakers or something, then it might really be acceptable. So I start with 24. Which is, if you had headphones on, then you hear clearly the stereo image. The presence is there. There are also high frequencies in there, and it's a usable quality. Of course, not good, but the bitrate is really very low. Okay, now I will push it to the extreme and go to the 12 kilobit, and we listen again, which is really very tiny. Okay. Yeah, I'll stop here. So yeah, I guess the stereo image a little bit narrower, more artifacts, of course, but it's, yeah, keep in mind it's 12 kilobits, so for that, still quite okay. Yeah, and the XHEAC is being used in our Xtreme encoder, and the encoder is certified under that under the trademark program of Fraunhofer. So it's officially supported and usable for that use case. Okay, I'll switch over to Dolby Atmos. The applications here are immersive live radio and immersive podcasting. The use cases we support here are packaging of pre-encoded files, which come from a Dolby Atmos production studio, or we can provide encoding from a master file that comes out of that ourselves. We have various spatial formats that can be supported, 514, 714, or others. Dolby Atmos is packaged in containers, the Dolby Digital Plus, it's the enhanced AC3 or AC4 usually. And there are, with that Dolby Atmos suite, software suites, options for spatial rendering or upmixing. So you can take your 5.1.4 stream and render it to a binaural stereo signal on our encoder and deliver that as one variant in your stream. Or if you have a mixed program which is not fully immersive, which is usually the case, only some, for example, there is some intermediate program which is not immersive. You can take your regular stereo stream and upmix it to Dolby Atmos, which gives it some kind of spatial flavor. It's upmixing, of course. It's not comparable, but the signal will fit in better, let's say, with a immersive program. Here's also an example of how we can use it in HLS. That's a manifest that drops out of our encoder. Here you see two variants. That is a audio object type 2. So there's an AAC fallback here. And here's the Dolby Digital Plus Atmos variant on the bottom. And denoted here with channel count. Maybe if you encounter it, don't get confused. Channels 12 doesn't mean that it has 12 channels hidden in the standard. It's a complexity index, they call it for the decoder. So it's just an indication to the decoder that to check if it's compatible. Okay, we've done with partners example productions and supported them with our encoder. So that was the Deutschland Radio and specifically their stations Deutschlandfunk Kultur. And they have produced two podcasts last year. That was the $1 Billion Apes podcast in Dolby Atmos, and this year Who Killed Tupper, also an interesting podcast, fully produced in Dolby Atmos. And yeah, we could support that with our HLS encoder. All right, I have a second topic which I want to switch over to now, which is also important in radio and always topic of discussion, metadata insertion. And yeah, if you work on metadata, you feel like this guy. Can be a tedious job sometimes because there is no universal standard on how to handle that. And yeah, we have the job at the encoder, which is kind of central to that infrastructure, to deal with plethora of options there. And yeah, I can show you how we do it. And that's our concept in our software to deal with metadata. Metadata is represented as objects here at the center. Object means that's the database entry with the metadata, which can be the song title as usual, but it can also be a picture and even more, or subtitles, even whatever you want. And associated with that database entry is a method how to get it into the system and how to put it out from the system. And outputs, there are two options. We have protocols that go directly out to some other remote site, or we have methods to inject that into our audio streams. And this is an audio pipe as we use it in our software. And there's one element which we call metadata inserter, which feeds the metadata in that audio processing chain. Okay, I'll start with the ingest methods. There are a lot of options that we offer. First are the push options, which are mostly used. We have an API, a REST API, and you can update metadata regularly with push and with our API on the push side. And the other option is you have already an RDS UECP infrastructure running with metadata, and we can receive that as well and update our metadata objects from that. There's also pull mode. We can fetch text files, for example, from an HTTP server and update metadata from that. Or we can reuse metadata that is received from incoming audio streams. So just pass the Icecast stream, get the metadata from that, and you can reuse it anywhere you want. We can extract metadata from the configured demultiplexers, so the DAB radio text or FM radio text or DVB metadata that can be extracted. It is made available and can be used anywhere you want. We can extract metadata from program schedules, from scheduling software, in particular Music Master. And another update method are webhooks, which is then quite simple. Then how to use the metadata in audio streams. This is a closer look on the metadata inserter element that we use. There are 3 layers, actually, base, overlay, and fallback that can be configured. So you have to select 3 sets, or you can select 3 sets of metadata. And the intention here is that you have a base set which contains the static information, which does not usually change over time. It can be the station name or website or whatever. So a link to the website. And then the second one is the overlay one, which has dynamic information, that is the song title, which is constantly being changed, for example, via push or pull. And then you can configure a fallback metadata that is activated if your update mechanism fails for some reason. Then it makes sure that the song title doesn't persist for a long time. It just switches back after a fallback period to a fallback title, for example. And you can, of course, configure here that you do not want to use that at all, but just pass on the metadata that is received, for example, from the DMAX or the Icecast at the input. Right. So that was the output via our generated audio streams, but we also have a direct output of metadata in other formats. Okay, those are the formats which we support, of course, for output. We can have file container formats. It's the usual ones, you know, ID3 in MP4. There's metadata support and also others. We also support chapters there, which is in some interesting for podcasts, I would say, so that you can jump to specific spots and navigate more smoothly in your podcast. Then, of course, there's protocol-specific metadata. The usual suspects are here. Also, Tobias mentioned the HLS has also a method for chapter support. We do have that, and soon there will also be a method to enhance the HLS with transcribed text, for example. That's called the web VTT. So we have transcribed subtitles in there. We can also generate UECP from our metadata, so that we generate a radio text signal which can be used in MPEG-TS, for example, or as ancillary data in some codec or something. Okay, then the direct output here is not related to audio streams in our system, but we can pass on the metadata in certain formats. For example, we encode the UECP and relay it via UDP to some other devices. Or we have also CDN-specific protocols, namely here the QuantumCast or Galaxy, they have been renamed. Metaport, which is CDN-specific, of course, but that's also an option we can support. That was my part. I think I'll hand over to Thomas.
Okay. So yeah, welcome also from my side. I want to show you some stuff about technologies for your workflow optimization. And to give a brief overview, Here we go. There are some points on the list. The first one would be high-res catch-up mode. I will explain in a second what this is. Smooth delay, some points about HLS segment length, and then also applets I want to show a little bit. So what is high-res HLS catch-up? So if you're using HLS setup with main and backup encoders, you're streaming 2 streams to your CDN and you use long playlists for time shift, then you have a problem if you are doing, for example, an update of one of the encoders, because if you update it, then it starts creating the playlist again. So at the beginning, you only have a few segments and you can't do the time shift. So we have developed counterpart catch-up. For this, you have a setting it to none, then you will just use plain HLS. So you generate some segments and upload it after you generated 2 or 3. Then you have this short playlist, but you can't do time shifting then. Another mode is gather. It actually waits until the playlist is complete. So all segments are generated once. For example, if you're having playlist length of 2 hours, then you wait 2 hours until the playlist is complete, and then you start the upload. That the advantage is that you will always have a window back in time, so for the time shifting, but you will have to wait 2 hours until you have main and backup back. So that's not so nice, and that's why we actually developed the transfer mode. And the idea behind that is that you get the media segments that you do not have when you restart the pipe. You will actually download it from the CDN from the other server so that you can build up the playlist very fast. And one point is that you actually have a bandwidth limit. So if you're having like 200 pipes and download 2 hours of segments from the CDN and all pipes are restarted, then that's maybe not a good idea because your downlink will be quite crowded and maybe causes issues on other services. So maybe don't do that. So we have inserted the bandwidth limit, and actually if it's set to 2 times, for example, it only downloads 2 segments if one is produced. So for example, if you have a 2 hours playlist, it reduces the time to less than 1 hour. And if it doesn't work because, for example, both main and backup were restarted, then you can also select a fallback mechanism, and so that actually at least one is doing segments on the server. So next up we have smooth delay. So you can see the smooth delay processing pipe element on the top right. If you are familiar with Xtreme, you recognize it. And the idea behind that is that you can set a target delay. For example, if you want to do a audio video sync, and we also have some adaptation for that, and you can set a speed factor. And if you change the delay, it takes some time to catch up, but it's smoothly delayed. So for example, if you set the speed factor for 50 milliseconds for each second you play, then you will need no distortions or something like that. But if you set it, for example, for 1 second, then quite audible, but you can decide what you want. And we also have a dashboard widget for that, where you can actually set a maximum delay and a minimum delay, and then you get some sliders where you can set the delay with the slider, and you will see with the green one here which delay you have at that moment. So if you put it up, then it slowly smoothes the delay. So next I want to talk a little bit about HLS segment length. So because HLS always introduces at least 1.5 to 2 times segments length delay, the idea to lower that delay is to reduce the segment length. And in Xtreme, it's possible to use 2-second segments or even lower. And that reduces the overall delay so that you don't have so much. So you are comparable, for example, to Icecast or other streaming services. Next up in the row is applets. Applets is one thing we integrated in Xtreme because we wanted to have if this then that mechanism. So we have a lot of triggers, and if they are triggered, they do some action. And example triggers are here, for example, date and time, pipe changes. So if, for example, if one of the pipes is playing and stops, then you can trigger something. We have lock events, which are have codes. For example, W1012 is a warning that level is measured below a threshold you can set. And based on that, you can do something. We have quick actions, which are actually the dashboard buttons. So you have in the dashboard, you can define some buttons and say, if you click that, then do this. And also we have triggers based on alarms, which are shown for pipe and system errors. And some examples for actions are logging. So you can create an extra log entry. You can also send out webhooks to other hosts to say, okay, I have an error. I want to do something about it. You can change pipe and pipe groups. If you, for example, want to start a special program at 12 in the night, then you can do that with a date trigger and this action. You can send messages. For example, we use this extensively for alarms. So if you get an alarm, you can send an email. You can make a SIP call. You can change states. For example, activate another applet so that you can do a chain of applets. You can upload a file to the archive, and you can also do a system reboot, for an example. And one nice thing is that you can use placeholders in your actions. For example, you can set the host name or the alarm action or event messages. That's, for example, useful in the emails so that you can actually have more information in the email about the trigger that actually triggers the action. So my next part is about audio processing and loudness control. So we had two webinars, the last two webinars with Hans van Zopten from Timio, and we actually integrated his stereo tool in Xtreme since version 3.8. We implemented this as a processing pipe element, and it does some really sophisticated audio processing. You really have to have a look at the last two webinars that were really great, and he explained a lot of stuff about audio processing. And we can also do micro MPX generation with that. And for example, you can see here one pipeline of such a stereo tool processing. We are just using a URL source, so that's just an internet station, and we put it into the stereo tool, and then you can click on the symbol you see here, and then you are led to the Timio web GUI so that you can just use stereo tools as you know it. It's opened in a separate tab in your browser, so you can just edit stuff here. You can select presets and so on. And that's really nice. Last but not least, I want to tell you something about our loudness control. We call it next generation loudness control, and is available for pre-processing of files since version 3.7, and is, for example, used in the Klassik Radio use case Tobias will show later. And you have some parameters that you can set, so target loudness and target true peak. And we have some presets created by well-known audio engineers, and we also have a UI tool for creation of this adapted profiles. And I will give you a brief overview over that. So this is the GUI tool that you can load files and set parameters. So we start looking at the left side. So you can see a file that you've loaded. Its length, its loudness, its loudness range, and its true peak. And you can also see if you have processed the signal, what its outcome loudness range and loudness and true peak was. And you can also save the file and its gains. So that's very sophisticated. And on the right side, you can set some target parameters and also parameters for the leveler and the limiter. If you have processed some file, you get out some plot like this. So on the top, you see the signal in processed and unprocessed. So one is unprocessed, one is after the leveler, and one is after the limiter. And if you have a look at the correction gains at the bottom, you see that the blue curve is actually the correction gain that would be necessary to reach your target loudness. That's not very useful because it changes all the time and if everything is at the same loudness, it sounds very bad. So you want to have some dynamics. And so the leveler, which is the orange curve, is doing only the correction in a certain way. And also it tries to not to change too much the loudness. So you see that that's quite steady. And after that, you have the limiter, which actually takes out the peaks. And we have another limiter now included, which actually is a, how's it called, oversampling leveler, which also has some more improvements in that. Yeah, in addition, there is the parameter set iterator. So based on the input loudness and input range and true peak, you can define different sets. And if you have a look at the graph in the middle, then you see that if the parameters of the input signal fall in the blue part, then it will only scale the signal. So it will not do any dynamic compression or leveling. It will just increase or decrease the loudness by simply adding a constant factor. But if you need more compression, then you actually have to use the leveler and limiter, and that's the orange and green part and the gray part of the graph. And the sets B, C, and D do more aggressive leveling and limiting to reach your goals. Yeah, so the leveler and limiter, so there are 4 different sets, as I showed there before. You can do automatic switching dependent on the input signal. It's also used in Xtreme. So you just have to put the parameter set in there. It's an iterative process considering the EBU R128 loudness, the true peak, and the EBU check 3342 loudness range. So, and the idea is that you get a consistent loudness even for longer pieces with different sections. So that's a very nice thing, and it's very good at that. Yeah, so yeah, you can use it by using the parameter sets in Xtreme, and some little outlook would be that we try to adapt the algorithm to work in real time, or at least near real work time in the future. Yeah, that's it for my part, and I'd like to hand over to Tobias.
We wanted to show you some examples of how streaming can be integrated into different use cases and how we have done that. So first, this is the WDR, the West German public broadcaster. As you might be aware, the German public broadcasters are very heavily regionalized. What is probably most noteworthy here is the fact, referring back to what we said earlier about the scalability and the flexibility, is that originally in the WDR use case, both their streaming, which in this case, as you can see on the diagram here, both includes HLS streaming with AAC, unsurprisingly, but also Icecast streaming with MP3. So both formats are used and supported in this case. And the multiplexing of their DVB compliant MPEG-TS were happening on the same systems from the same AES67 inputs. So that's actually a fairly great example of the flexibility in action there. And of course, as you can imagine, they also have a fairly high number of streams, as you can see there, which are of course also handled accordingly. Then actually our largest use case by sheer number of outputs, that is Radio Nacional de España in Spain, of course. Somewhat unusual also on the input side there, because there it's not like an analog, digital, or even A67 kind of input that is coming in, but actually an MPEG-TS of 128 programs, which are demuxed, or the MPEG-TS is demuxed in our system, and then encoded in various formats, including MP3, AAC, even AC3, so Dolby formats, and then distributed on to the CDN, all sorts of streaming formats, Icecast, RTMP, even HLS, and Dash. And because of this, the sheer number of input programs and the number of different formats, different encodings, and of course, different qualities that are output, we are actually arriving at just about 700 outputs that are coming out of our system there. As I mentioned, of course, as you would expect, streamed to the CDN or CDNs, and from there made available to the listeners. And the last use cases we wanted to show here, probably the most complex as far as interlocking mechanisms at work goes. This is Klassik Radio, a private German broadcaster, a commercial broadcaster. What's unusual there is that we also use our API to take scheduled radio program via, scheduled via Music Master, and then realize this in our system. So we receive the Music Master schedule, and then, of course, pull the audio files from their audio database as required. Do, of course, the encoding, but also things like the loudness processing. We talked about the NGLC earlier, adding things like Q in and Q out points and those sorts of things before doing, well, actually two things there, because Klassik Radio has both a freemium and a premium program. The freemium program are 50 Icecast streams that are simply playing out as a regular live radio effectively, according to the schedule that was created in Music Master. But they also have a premium program where the listeners, the clients, can actually set up their own playlists, sort of like, for instance, in Spotify or something similar. And for that, we ensure that the entire audio catalog is available, encoded, and processed as Klassik Radio wants, and of course available on the CDN side. So we are doing the entire audio processing for this project. With that, we are closing in on the end. Yes, as Thomas has already written, the important part here is continuous streams. So the answers we've gotten aren't really wrong, in the sense that they're, of course, real things, and they were a kind of internet radio, though there are kind of, catches to a lot of them. In the case of the Internet Talk Radio 1993, the issue is that basically it was just files that were made available on the internet. So in that sense, it was internet radio, but not a stream in that sense. As far as actually the Guinness World Records are concerned, the first continuous live radio stream was created in February 1994 by Radio HK in the USA. In fact, how they did it, they had simply an audio CD, self-made audio CD, self-burned, etc., hooked up to a web conferencing reflector that basically served as the streaming platform there. And this way, of course, you had a continuous program that people could actually just ad hoc hook themselves into and listen to. Of course, still a very far stretch away from the streaming that we have nowadays. Unfortunately, no one was able to guess this, but maybe we can still have like a consolation prize to Florian for the participation. There were some good guesses there.
So thanks, Tobias, Bernd, and Thomas for your presentations. We are now reaching the end of this webinar. We hope you found it valuable. If you have any questions, or if you like a personalized demo, please feel free to contact Tobias, our product expert. And we look forward to seeing you in our future webinars. Thank you again for your time, and have a great day.
Have a great day. Bye-bye.